Welcome again. Remember, in our last lesson, we talked about the separation of the angular part and the radial part. We had two parts, and now this lesson, I want to look at the solution of the angular part, which the first thing I'll do is the separation of the theta part and the phi part. Because remember what we had in the angular part. We had one part having the theta part, another one having the angular the phi part, sorry. The other one, the first part is having the theta part, and also we have this one as having the phi part. So recall that we came up with the angular part this manner. So we had sine theta d theta into sine theta dy over d theta plus d squared y over d phi squared plus ay sine squared theta being equal to 0. Let this one in this case now be our equation 1. So this equation 1 is still a PDE, that is the partial differential equation. So by the separation of variables, we want to let, I have y here, I have y. Let y be equals to theta and phi, such that theta is equal to theta as a function of theta, and phi is also equal to phi as a function of phi. So the same thing we did to come up with the radial and the angular part, we are going to substitute. Look at this one. I have y. Here I have as a function of theta. That means I'm going to bring theta inside. Then I take phi as the coefficient. This part here, I'm going to multiply because I have y here. But this one is a function of phi. So I bring phi here. Then I multiply by theta as a coefficient. This third term also, y is here. That means I multiply by both theta and phi. If I do that, I'm going to have phi sine theta d theta. But remember in this case now, if you can look at this, I have theta. It means now I change it to a full derivative. Now I'm not going to have a partial. I now come to a full derivative. So I'm going to have phi sine theta d theta into sine theta d theta over d theta plus theta d squared phi over the phi squared plus a phi or a theta phi sine squared theta. Remember, I've just substituted y with theta phi because remember I said y to be theta phi. So if I substitute, I'm going to have a theta phi sine squared theta. The next thing I do, I let y to be theta y. I multiply. Another thing I do, dividing through by theta phi. So if I divide that, here if I divide by theta phi, it means phi will cancel phi. I remain with 1 over theta sine theta d theta into sine theta d theta over d theta. Plus, here I divide by 1 by theta phi. It means theta will go with theta, I remain with phi. So I'm going to remain with 1 over phi d squared phi over the phi squared plus, here if I divide by theta phi, I remain with 1 for all this. Then I'm going to have now a sine squared theta. So that is what I have here. So I have, lastly, I have 1 over theta sine theta d theta into sine theta d theta over d theta plus 1 over phi d squared phi over the phi squared plus a sine squared theta is equals to 0. So if I have these two parts, look at the first term. The first term is dependent on theta. The third term is dependent on theta. I collect them together. And also the second term is dependent on phi. So also that one I collect together. So let me do this. Let me take the ones dependent on theta on the left hand side, the ones dependent on phi on the right hand side. Let's see what you're going to have. So at that, let me have this. I have the ones dependent on theta. That means I'm going to have 1 over theta sine theta d theta into sine theta d theta over d theta plus a sine squared theta being equal to, remember the other one, if I take it to the right hand side, it will be now negative. So I have negative 1 over phi d squared phi over the phi squared. The same thing we did when we were coming up with the angular part and the radial part. Look at this. This side, the left hand side is equal to the right hand side, but they can only be equal if we, let's say, equate each term to a constant b. So this phi, the left hand side I equate to b, the right hand side also I equate to b. So if I equate this one to b, the right hand side, I'm going to have negative 1 over phi d squared over d phi, d squared d phi over d phi squared being equals to b, of which if I rearrange, I'm going to have d squared phi over d phi squared plus b phi is equal to 0, because I've just done this one. I multiply here by negative, I divide by negative, sorry, I'm going to have positive. Here also I divide by negative, I'm going to have a negative. Then I multiply by phi, here this phi will cancel phi, then here I multiply by phi. But remember it is negative, so if I bring it to the left hand side, it will be a plus. That is why I have d squared phi over d phi squared plus b phi being equal to 0. This one becomes my phi part. So remember, in this lesson our main objective was to come up with the phi part and the theta part of the angular part. Remember, we had angular part, but we further separated to have a phi part and then theta part. So this one becomes my phi part. This one becomes my phi part. The next thing I do, remember this part here also is my theta part because it is dependent on theta. So this part also I equate to b, I equate to b. So if I equate to b, I'm going to have 1 over theta sine theta d theta into sine theta d theta over d theta plus a sine squared theta being equals to b. So I'll do this. I want to make sure I do away with this fraction here, theta. That means I'll multiply by theta. I multiply here by theta. Also here I multiply by theta. If after multiplying that, I divide through by sine squared theta. So let me have this. If I multiply by theta, it means this one will disappear. But I'll have theta multiplying the whole of this function. Here also I have this one, theta multiplying the whole of that. Then I divide by sine squared theta. If I divide by sine squared theta, lastly I'll be having, then I rearrange. I'm going to have 1 over sine theta, because here I have sine theta, divide by sine squared theta, I remain with 1 over sine theta d theta into sine theta d theta over d theta, which I have here, plus, remember I have sine squared theta here. If that case I divide by sine squared theta, I'm going to remain with a. Then I bring this one also as a function of theta. I divide by sine squared theta, it means I'm going to have b over sine squared theta, but remember all of them are as a function of theta, so I'm going to have this theta is operating on that being equals to 0. So this one becomes my theta part. This one becomes my theta part. So theta part is just 1 over sine theta d theta into sine theta d theta over d theta plus a minus b over sine squared theta into theta uppercase is equal to 0. So this one is my theta part. So I've used that one. By the separation of variables, I've come up with the phi part and also the theta part. So I hope that lesson is okay to you, and follow that procedure to do more, because the next thing we are going to do is now the solution of the theta part and also the phi part. But I'll start with the phi part, then I go to the theta part. Welcome. I hope the lesson is enjoyable to you and expect more. Loading.